It's still crazy that for you it's like 6 in the morning on a Wednesday, where just started my Tuesday.
Yeah, we're in the future. Morning all and
Hmm.
welcome. So today we'll be discussing AI Foundry and Semantic Kernel with the great Peter. So thank you, Peter, for coming and chatting to us today.
Thanks for having me. Always fun.
So this session is delivered on behalf of like the Azure Cloud Commanders Learning Room. So you can find this learning room and other learning rooms at aka.ms/learning rooms. It's a Microsoft Teams-based community. It exists to sort of help you get certified, learn about Azure. It's all free. There's sessions and different topics such as Azure infrastructure, data AI. Different groups are doing different sessions. So yeah, just go to the link, take a look at the learning rooms, and then join the relevant learning rooms. You can be a member of one or more learning rooms. So yeah, it's a really great initiative by Microsoft in order to deliver this for the community worldwide. So this session is being recorded for those who can't make it. We try and record them so that people across the world don't have to get up as early as some people to view some of these recordings. And if the recordings are on during the workday, you may have other commitments that you need to attend to. So because of that, if you do not consent to being part of a recorded session, please disconnect your line. As attendees, your name is hidden on the recording. However, if you do come off mute or have your camera on, your voice and video will be recorded along with anything that you may mention. So try not to mention company names, etc. The recording will be published later. The link will be posted in the learning room. So just code of conduct. So it's just an inclusive session. So be welcoming and respectful to everyone, friendly, considerate. People are coming from all breadths and depths of life. So yeah, welcome in. There's no stupid questions. Raise your hand if you want to ask a question or use the chat. I'll be monitoring the chat throughout this session. And if you have trouble trying to see something that's shared on the screen, on the lower left-hand side of the Teams share window, there'll be a plus and a minus symbol. You can actually zoom in and out of the content being delivered as well, which is really handy to have if you need to see it, like a tiny bit of text that may be being shared. So keep that in mind. So yeah, today we have the great Peter DeTender. He's a Microsoft trainer, keynote speaker, home baking fan. Peter's come and talk to us about different sessions before, so it's great to have you back, Peter. I'm sure you'll do more of a better introduction, but yeah, thank you very much, and over to you.
Pretty cool. For some reason, not too important, I would say for now, but it tells me that chat is only available during the meeting. So I cannot use chat myself, but I'm not sure if I actually need to use it. If there's any links or something, then maybe remind me that I send them through later on.
Okay. Yep.
But no, with that, I would say, as always, it's a joy to not only present. I mean, it's what I do for a living, but apart from that, it's always fun to just share knowledge with like people I call friends, and you know you're one of them. So it's always fun to get an email from you like, oh, we got some space in our schedule. Could you come up with another new interesting topic to talk about? And that's how we ended up with initially AI Studio, I think a few months ago. And then because of the name change out of the Ignite conference in November, I think it was a perfect spot to bring it back, but then using the new name and zooming in on some new capabilities. So that's why I called this session the Azure AI Foundry Beyond Playground. And hopefully out of the story and mostly demos I'm going to try and walk you through, it should be clear what I mean by Beyond Chat Playground. So I'll share a bit. I mean, thanks for the nice introduction. First of all, I would say it's funny because I never talk about my home baking passion in any of my own presentations. So it's a good reminder to actually maybe pick that up and add that as well. So in short, Microsoft Technical Trainer, been, I would say, a technical trainer for a big part of my career, not full-time job, but typically mixing consulting with training with architecting, and then moved into the Microsoft role a bit more than 5 years ago, initially out of Belgium, covering West Europe and EMEA, and then moved to Redmond 3 years and a week ago or something, but still in the same role. And then gradually shifted from Azure infra architecting to DevOps and developing. And then obviously now with the core focus of Microsoft on AI and Copilot, it shouldn't be surprising that our training offering is also shifting into that direction. So I only got a few slides, and maybe I'm not even using all of them, but the idea is to really, I would say, take a few steps back maybe on not getting blasted with AI anymore. Now, what do I mean by that? So about 18 months ago, Microsoft came up with hey, this AI thing is becoming quite important, where it was all AI, 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 and at the same time, Copilot. And a lot of customers loved it. A lot of organizations jumped onto it, but then also finding out that it is actually a lot harder in a way that you do not always find what you need, I would say, using Copilot, not breaking down the solution, but it's where a lot of organizations are already, I would say, surfing the hype, right? Where it's oh my God, we got OpenAI 18 months ago, and it's this super promising generative AI tool, and it can do everything from writing essays, obviously killing universities and colleges because it's a big part of what students are doing there, but then also in your day-to-day job, replacing people, automating tasks was one of the rumors. We no longer need junior developers because we got GitHub Copilot writing code and all that fun stuff, but then also seeing capabilities, opportunities at customers where after using it, after I would say the first hype, they actually find out that it's a lot more that comes into the picture once you start thinking about building your own AI scenarios, which I would say within Microsoft we describe as developing custom copilots. There's two different trainings actually that we offer. Huge amount on the Learn platform that all points to custom developing your copilots. And I've been going through this ride as well because I mean, again, it's part of our job offering to provide customers with that kind of training. But then in meantime, also finding out that only 1 year in, so many customers are already thinking about the next step. And that's a bit what I wanted to share in the next 45, 50 minutes as well. So if you got questions, I would say post them in chat. I know, Luke, you're watching over. And if you want to see anything happening on screen in a demo that you're missing, then I would say also let me know. Now, the starting point is it's no longer about we're just going to use Copilot or we're going to use any of the other generative AI tools. But obviously within the Microsoft stack, it's all about using Copilot in Azure, in GitHub, in M365. But that's only giving you, I would say, a limited set of capabilities. So what we're now moving into is customers being ready to take that next step. And that's where you need to start maybe developing your own scenarios or your own solutions. Now, the starting point here is, okay, what do I need to actually integrate AI into my solutions? So the starting point, and I'm not going to list up all of them, but the starting point obviously is your development environment. So you're going to develop using Visual Studio VS Code, maybe some other development platform, that's all fine. Then second, maybe I would say looking at myself, I'm heavily relying on GitHub Copilot. So it's the Copilot generative AI tool allowing you to not only write code or being that what I call the peer program friend, because in the past you would rely on maybe one of your colleagues, typically a more senior, more experienced developer in that specific language, and you would reach out to them to ask questions. We're now maybe a bit unfortunate for your friend, but you are now leaning towards GitHub Copilot to help you with that. to write code, but also to document code, to explain code. I'm not a developer because I'm a trainer, but I can write demo applications. And a big part of the fact that I can do that is because of Copilot in GitHub. Then obviously, behind the scenes, you need some AI services, where now the complexity is traditional AI and generative AI. The management interface, the biggest part of what I'll talk about, is now AI Foundry, but everyone still calls it AI Studio because that name has been around for about 18 months, maybe a bit longer. But that's also where the name change actually emphasizes that it's a lot more than just that one part of managing your AI environment. Then AI Builder is about the same, but more on the Power App side, so the low code, no code scenario, where it still allows you to build powerful workflows, but not always zooming in on all the characteristics of what a full end-to-end AI solution could need from a development perspective. And then obviously the large language models, I'll talk about that a little bit later on, but that's really where the intelligence comes in. Without large language models trained on public internet data, there wouldn't even be generative AI. So that's another part in the stack. And then it keeps on coming, right? There's a lot more. So we got Copilot Studio, we got machine learning. If you really want to build out your own trained model, like the OpenAI ones are not good enough for what you need, or you want to build real specific ones, then that's where you might bump into machine learning and Machine Learning Studio. And then the last two ones, LangChain, PromptFlow, Semantic Kernel. I'll talk briefly about, at least PromptFlow and Semantic Kernel. It's what they call a RAG architecture, so retrieval augmented generation. Because if you think about what your generative AI, the large language model, can give you, it's everything that the model has been trained on. And easy said, using OpenAI as an easy example, it's basically all public information available on the internet up to about a year. But if you would ask something like, what's the weather like in Seattle today? Your large language model would not be able to tell you. And that's where we need that extra level of intelligence to provide you real-time information, to provide maybe company-specific information. So a little bit what like M365 is doing. Using Microsoft Graph, you ask Copilot in M365, like find all emails from my manager, then it's going to perform a call to Graph, like who's your manager in the organization, then connecting to Exchange Online, reading out your emails, stuff like that. And that's not coming from the large language model. Now, it also means that managing your AI project is now becoming a lot more complex than ever developing something in whatever language. So to help developers and organizations, obviously, with the whole management aspect of all this, that's where AI Foundry comes in. So in short, AI Foundry is our Azure AI central management portal, if you want. It's a dedicated portal. ai.azure.com is the way to get there. And it's going to allow you to interact with models, creating the models, fine-tuning models, benchmarking. I'll show you a bit on that, but also using the playground. And that's really, I would say, the starting point, where you're going to deploy a model, testing if it actually responds to a prompt, and then going through all the advanced stuff. Now, looking at the Azure portfolio, in the end, it's almost like just an extra level of and yet another Azure resource. Because you deploy Azure, you want to build a web application, you want to make it, I don't know, generative AI inspired, influenced, AI ready, and you're just going to deploy another service. Starting point is Azure AI Service, but it's a bit complex, and I'll show you that in a demo. On top of that, you need to decide what kind of Azure AI service do I need. So that's what you see here on the left-hand side, where you got a lot of different ones. And the funny thing is that AI has been in Azure since, at least what I know, 2016, 17, providing services that we now call traditional AI, using document intelligence, using the translation, speech recognition, face recognition, all that fun stuff. And it was already there, but now it's, thanks to generative AI, I would say, it's actually becoming even more important, where On the other side, a lot of the traditional AI capabilities are now actually getting replaced, overruled by generative AI as well. If you would upload like a PDF document with an invoice, you could actually go like, hey, Copilot, can you describe what this document is about? Extract all the key information in a table, and it would actually do that for you, where you don't really need to use that document intelligence from the past anymore. Then AI search is the engine to add that augmented information, like adding more real-time, more company-specific information into it. And then ultimately, if you look at it from a data science perspective, you're going to deploy Azure Machine Learning. And again, these are just all options. Not all customers are going through all motions, but then also finding out that managing all of this, traditional AI, generative AI, search, and then last, the machine learning, in the end, it was 10, 15 different portals that you had to go through. And the idea is now that all of that is getting centralized using AI Foundry. You still have some of these standalone portals, but the mindset is moving as much as possible into that single AI Foundry dashboard. So that's the starting point. So I'm going to bring in a first set of demos here. And I already pre-deployed some stuff to speed up the demos, but in the end, it should not all be that hard. So the starting point is my Azure portal. Make it a little bit bigger. There we go. So as always, you got the resource group. I have one for AI Foundry. I mean, how hard can naming conventions be? And I'm deploying some stuff. So I deployed over here Azure AI Services. Then I got another one, Azure AI Services, and a few other building blocks. Now, depending a bit how you get started in your AI deployment or resource deployment, you're going to see only one of those services, or you're going to see multiple of them. So how does it work? Like anything else, you go into your resource group, create new Azure AI service. Well, now you're going to see that we have two of them. So I would say the one that you need to look for is the one with the cooler icon. That's how I describe it. Why? Because this is the old one. It's still there. It's pointing to the traditional AI, but the recommendation is to start using the new one. The nice thing is that inside Foundry, you get access to the generative AI components, and you still get access to all the traditional AI components as well. The fact that it's still there, it's a question coming up in almost any workshop, like, why are we not getting rid of it? It's backwards supportability for customers who are still using it. So from here, it's pretty straightforward. You create a new service, you provide all the traditional Azure settings, the location, the resource group, the pricing. Obviously, any resource in Azure typically comes with a cost. And once you've done that, you're going to navigate. Oops, I didn't need to close that. You're going to navigate back to your AI resource. And it's not going to show you a lot. So what it's doing here is showing you the different resource object, like again, a storage account, a virtual machine. But once you dive in, it's not really showing you a lot from here. Why not? Because it's just a service placeholder. That's where now taking the next step is moving to AI Foundry. The reasoning behind this, by the way, is what we call the control plane and management plane. Think of this as your Azure cloud team, your cloud, I don't know, center of excellence, right? They're typically the ones managing the Azure part of the solution, where now you as a developer, you're going to come in and you're going to build your application, and you just need connectivity to an Azure service. The same thing with a storage account. So you would have your cloud team deploying Azure storage, but they would not get access to the actual data, where now the developer or the application the developer is building actually needs access. It's the same mindset. Like, you're going to manage the Azure part of it using the Azure portal. But if you really want to dig in the actual solutioning, that's where you're going to use the AI Foundry portal. So after deploying, you have something in the AI Foundry. So again, the short link is ai.azure.com. And if you don't know, then obviously you just open the service and you click that button, it's going to redirect you. Now from here, you can start deploying your resources. Now to interact with an AI service, like pretty much any other cloud service, it's an API endpoint. So you need a URL and you need credentials to provide that connection string, but it's a secret, it's a key that you need. And then you might end up in a scenario where I'm Peter, I want to build my app, I'm going to deploy an AI service. And from there, we have our resource ready in Azure. But then my colleague is doing the same thing. And my other 50 developers are now also doing the same thing. And that's where managing all those AI services also became a nightmare. So what's the new approach? It's what you see up here, using hubs and project. So we actually integrated some sort of a topology as part of your AI service, where you would deploy a service, and underneath, once you have the Azure resource live, like a placeholder, you're going to build a hub and a project. The idea is within hubs and project, you're going to define permissions like traditional RBAC. Who of my developer team can actually use specific services within? So instead of deploying 50 standalone AI services, you're going to deploy maybe one of them, preferably two, for high availability of the endpoints. But then on the lower level, you're going to allow developers, like a sales app, you're going to connect to the sales hub of the project. And the marketing application that needs generative AI, you're going to connect to the marketing project. So it's just a different level in the topology. I got two of them. So I got a hub, got a project. You can create multiple hubs. You can link multiple projects to a single hub. So that's, again, just a topology. So that's the starting point. So we have the service deployed. We created our AI service. And next to that, we create multiple hubs, multiple projects. And then the next step is obviously, how do I integrate my AI into the story? So the starting point is the famous, popular large language models. Used to be OpenAI in Azure. That was like option one, and basically the only option one. But in the meantime, we support a lot of different language models. So you still have the GPT ones, you have the Llama ones from Facebook, Meta. Phi is Microsoft internal ones, so created by Microsoft. You have, what's it called? Hugging Face. I still mix that up a little bit.
Hugging Face.
Yep. But so the idea is that it started with our partnership with OpenAI about 18 months ago. Still good, nothing wrong with it. But then obviously other players in the market also try to position their large language models. Now, one of the challenges I would say you have as, again, a solution developer is like, how do I know which language model to use? It used to be a lot easier because you had like one or two, like you would dive into the OpenAI GPT ones, and within GPT family of large language models, you would select GPT 3.5, and then you got version 4, in meantime 4.0, which is like the newest, latest, and greatest. And if you wanted to integrate text, you would use like a text embedding model, because the 3.5 and 4 was a bit too much, maybe too expensive as well. And if you want to create images, then it would be the DALL-E model, but they're all coming from OpenAI, where now you could integrate other vendor scenarios as well. So that's the next step in the story. We go back to our hub. We move into our project. Come on, move in the project. Let's do that again. No, Peter, it's this one. There we go. So from here, I'm going to walk you through at least some of those settings and features. So the first step is we got the project, and now we need to inject our model. So from here, it's pretty straightforward. You have access to all possible models that we publish. There's a lot more than what this screen is showing. And obviously, you can filter for them. And then you're going to find out that some of these, like the Hugging Face, is also called GPT to make it even more confusing. But that's details, I would say. So you would go with GPT 4.0, and you would deploy it. So deploying means building a little bridge, you could say, between the large language model. Think of it as a zip file. It's just a way to imagine it, right? It's obviously totally different, but it's running in Azure. So everything that you do in the interfacing is not leaving Azure, which obviously for a lot of customers is also important. Now, from here, you got a whole bunch of options to choose from. Within each model, you got different versions. Each and every of them are typically like a 1 year supportability. You can hook it up to one or more projects. And then important here is capacity. So what is capacity? I call it the virtual AI money, right? Where if you have that prompt conversation going on, input, output, and I'll show you that later on, each and every of your prompts, your questions basically, is consuming tokens. Next to that, you're going to define based on the requirements or the capabilities of the app, what a response could look like. It's also why, for example, you go to Copilot, the free edition, that the response is pretty limited in length, you could say, where if you use the paid licensed M365 Copilot and you still go to web, like use trained data, the prompt response is a lot longer. It's why we're giving you access to more tokens. You got more money to spend. That's how you have to think about it. Now, in a lot of cases, the default settings are maybe too much for what you need. So in this case, when I deploy GPT-4, it's suggesting 10,000 tokens. But what if you need to, or you want to build an app that only creates like a haiku? It's like not even 5 lines of text, right? It's maybe 50 characters. You don't need 10,000 tokens to do that. So based on the settings of the model, you can already tune the behavior of your app a little bit. Like if you would ask it to come up with a joke is typically like, 5 lines. You don't need 10,000 tokens to do that. So that's where you can play a bit with those settings. I already deployed it, so I'm not going to use it from here. And then also important is look at the actual cost. You can go to the OpenAI page in this case because I'm using OpenAI. But the thing is that behind each model, there is obviously a cost linked to the tokens. The more tokens you use, input, output, obviously the more expensive the bill will be at the end of the month. Interesting enough, the more recent language models are actually cheaper. So you could, let's say you want to do, for like a university, a case a few weeks ago in a workshop where they allow students to write essays. Now, let's say they want to write an essay on Greek mythology. Now, I'm pretty sure that nothing in Greek mythology is changing anymore because it happened like, I don't know how many thousand years ago. So finding that kind of information, getting the prompt response out of a GPT 3.5 or GPT 4 will still give you the same answer. So why would you spend time and money on a more expensive large language model if you know that the output will basically be the same? But I'll show you in another demo how you can actually test it, validate, and finding out a little bit about the timeline of a trained model. So you would add a single one, you would add multiple ones again, depending on the use case of your application. And then from there, you're going to start testing it, you're going to play with it. Now, before I'm jumping into the playground, I want to show you something else where it's sometimes a bit confusing. So what I did here is pre-deploying my service. So it's the same AI Foundry where I deployed a hub and a project. But now, for some reason, over here, it says Azure OpenAI Service, where if I go back to my previous step, it's the same thing. It's using AI Foundry up here. It's using the playground inside a project, but it's now not mentioning OpenAI service. So the reason why is because that OpenAI service project was actually migrated from the original OpenAI Studio. So that's where the portal capabilities, the options you have, like all the settings here on the side, might actually be different depending on when you deployed your project or when you deployed your service. So just wanted to emphasize to not make it more confusing. So in here, I have two GPT OpenAI language models, where now the next step is validating, is this language model providing the information that I'm looking for? So I'll start with 3.5. One of the questions that typically comes up is like, how do I know what kind of information it's been trained on? Like typically up to what date can it actually help me? Now, there used to be a time, like even in Copilot, where you could do like up to what date is your large language model been trained on? Or even asking, hey, Copilot, what large language model are you using? But that information is no longer visible. So I had a prompt that I used like, I don't know, probably already a year ago, asking who is the Prime Minister of the UK. Oh, I could actually do this for New Zealand, but I don't know if it got recently changed or not. But now using GPT 3.5, it tells me like, well, as of September 21, so that's giving you a rough timeline. Like I've been trained up to this date. The Prime Minister of the UK is Boris Johnson. Where now, if you're following politics a little bit, then you would go like, wait a minute, that information is no longer accurate. And again, think about this in, like, again, if you need to use this for like newspaper magazines, you need to use this for writing an essay on, I don't know, British politics or something, then out of the generative AI, you might end up with the wrong information. But now if we switch to GPT-4, we're going to ask the same prompt. The outcome is slightly different. So what's different without changing anything in the prompt? First of all, the date is more recent, which means that obviously GPT-4 has been trained on a more recent set of data. But next to that, besides the fact that it's providing more accurate information, the prompt response is also longer. So by design in the large language model, they can already tune the behavior of your app a little bit. Another interesting one is, besides doing your manual testing, right, is inside the models. Where did it move to? I'm sometimes still lost in the different interfaces myself. Let's see, model catalog. Well, somewhere there's an option to do benchmarking. Let's go back to the top. I could probably search for it, but oh, there we go. See, going back to the homepage is typically the way forward. Because now you got your different models, you can add more into it. And what it's going to tell you here, and again, just highlighting, not zooming in on all the details, it's going to tell you like, well, this is I would call it the industry, the customer satisfaction. To decide like for this kind of purpose, like is it just a question answering, like a Q&A bot from the past? Is it the text generation, like again, what you would use to write essays, help you creating business plans and do whatever? I have no idea. Some models are better in doing that kind of tasks than other models. And it's an interesting one because again, you could make it easy and go like, I'm going to use GPT 4.0 for everything because it's capable of doing a lot of different things in a good way. But then there might still be some reasons to not use a GPT model, but actually importing a specific one, maybe even from another vendor for the specific use case. And that's where over here, the benchmarking is actually helping you. So now we have our project up and running. We did some testing like, okay, cool, this is our project. But now we need to think about what's the next step. Oh, look, there's a hand up. Do you have a question?
Yeah, well, just one of the attendees asked a really good question around, and I was going to respond in chat, but I think it's better for the recording. So the question was, so regarding training of the AI, like when they go and ask a question, so that, for example, say they're in AI Foundry Playground and they ask a question and they've got data coming in from like the web, like they may have a hook going into Bing or something. Wouldn't And say you asked a question about like the Prime Minister, and then it's up to date as of today based on information that it's retrieved from the web. Wouldn't it retain that information and update the repository of the model itself?
No, not really. So, and then it depends a bit on like I would say the tooling you're using. So if you would use Copilot, for example, we're out of Microsoft pretty strict on the fact that we're not using your data. Like if you would upload a document, nothing of that information is getting stored. We're not using your prompts to train the model, which some vendors, including OpenAI directly, is actually doing. Now, as long as you're staying within the prompt session, it looks and feels like, oh, we have this continuous conversation going on. But once you close the session or you start a new chat conversation, it doesn't remember anything from that previous one. So,
because the models are essentially just, even though it may seem to us like humans, it may seem that it's very intelligent, but the models are actually just read only. Like the ability to inject data into it or retrain or even have it forget information would need to go through the training cycle again. So you need to pump the data in it and then use a whole lot of GPU capability to sort of retrain those models again. But this is where like the question is really timely, because how do you get it to retain the recent information? And I think you're about to discuss that with retrieval augmented generation and your custom copilots as well.
So that's where you would indeed like look into even the example with like the prime minister, right? So imagine it's giving you still, I would say, historical but recent history facts. But again, it's still not capable of telling me something about today. If I would ask it like, who's the new president in the US, it wouldn't know about it. So the fact that, for example, Copilot and again, other vendors provide you that kind of capability is now because of adding more intelligence, like real-time information into the large language model. So they're starting with, this is the large language model. All the information has been trained on up till a certain date. And now we're going to add our, for example, own knowledge into it. So that's where the RAG architecture comes in, where now you could store some parts of a conversation in like a database, like, I don't know, Cosmos DB, just one easy example, where as a user, if you would go back to like M365 Copilot, it knows, first of all, who you are based on the user account. It keeps track of your historical prompts, and it allows you to still pull up that information because it's storing that in a database. If you want to add information about your company, let's say you build like a sales alike Copilot, you're going to use a lot of the generative AI language, like natural language approach, allowing your users to just use their natural language to interact with the data. But then the data itself is no longer the trained information. It's what you provide in, I don't know, SharePoint. It's what you provide in like an Oracle sales application backend, something like that. And that's, I would say, the segue to this little piece. It's only one slide, but imagine you have Copilot, you're happy with it, but you want to make it more intelligent, smarter, more specific to your company. Then obviously the next question is like, do we need to really build our own model? And if so, which I guess that answer is yes, you should. What options do we have? So that's this little placeholder here where you got a few options. So you could obviously use Copilot. That's everything that comes with, at least for now, the OpenAI model. And we're going to interact more specific with M365 Copilot, and that's the hook into Microsoft Graph and giving you access to SharePoint, OneDrive, Teams, and Exchange Online. But what if your data is not in any of those two? You don't want the trained information from just Copilot, and you don't want to or you don't use M365. So that's where now you're going to build your own custom scenarios where you're going to use Copilot Studio. It's the non-code or low-code scenario. Or ultimately, that's what I'm talking about. You're going to use, oh, I need to update the slide. You're going to use your AI Studio. So I started with Foundry, so I'm taking a few steps ahead of this one. But the idea is that typically you're going to start with becoming familiar with Copilot, then moving to 365, and then moving to building your custom scenarios. Now, what you need to build it, so again, imagine that you're going to use your Azure AI Studio or Foundry now. And building more advanced scenarios, that's where you have prompt flow. So what is prompt flow in short? I'm going to skip a demo. It's super basic because I want to talk about Semantic Kernel as well and showing you a bit more what you can do with it. But prompt flow allows you to build like a step-by-step chat conversation behavior where the intelligence, like apart from the large language model, but bringing in the RAG architecture, pull up information from an Oracle database, pull up information from an Azure storage account, pull up information from, I don't know, the MSN weather website, right? Or the API calls at least. You need to write Python code. So prompt flow allows you to build a step-by-step chat conversation experience where you're going to start with an input, your prompt, the output is the prompt completion. And in between, you're going to rely on little snippets of Python code. So that's in short what prompt flow is doing. Another option about the same is LangChain. Maybe some of our attendees here heard about LangChain. It's the same concept. It's an open source framework, an SDK that allows you to integrate the language model, generative AI into your solutions. Another option is a Microsoft developed one, again, open source framework, is Semantic Kernel. Why do I like Semantic Kernel? I wouldn't say more than prompt flow, but prompt flow relies on Python. That's fine, but I'm not a developer. But if I develop something, then at least it's C#. So Semantic Kernel, although managed and developed by Microsoft, supports multiple languages. So it supports C#, still Python, obviously, but then also Java. I have no idea if they're looking into creating support for other languages, but it's already pretty extensive. So what you're going to do, I'm going to pull up a little architecture slide here. You're going to bring in different extensions, you could say, into your solution. So the starting point is always the same. You build your app, a web interface, whatever, console app, why not? And from there, you're going to inject the OpenAI service, like everything we did at the start of the presentation. You deploy AI service, you manage it through AI Foundry. You're going to play with your language models. And from there, you're going to add that augmentation piece into it. In this example here, the first option is what we call plugins. So just extensions connect to ChatGPT, integrating DALL-E to compose images, for example. Integrate information from Bing, integrate information from SharePoint, and so on and so on. Another option is what we call a planner, where a planner, think of it as an agent, but that's confusing because nowadays we all talk about agents like automating yourself using some generative AI intelligence. And then even the terminology planner is no longer valid because we now call them function calling. So a function is a little snippet of code, if you're familiar with Azure Functions, a little snippet of code that can perform one single task. So instead of you making an API call, it's actually bringing in the processing like calculations or translations or something already out of the function. And then the third one is a persona where the idea is that you're going to provide additional information to the AI engine. And you're going to tell like, hey, you're going to act as a sales manager. You're going to act as a technical trainer. You're going to act as, I don't know, someone who cannot respond to anything AWS related and so many other things. Or maybe you're the, I don't know, the home expert, chef, baking expert. Actually, maybe I should play with that a little bit. So the thing is, you're going to tune and really customize your scenario. I got a few slides. I'm quickly going to flip them. It's just how to integrate this Semantic kernel SDK into your applications. But I got a little bit more interactive scenario. Perfect time, got about 10 minutes to actually walk you through some .NET code and at the same time showing you how Semantic kernel is actually working. It's a new approach that I have for doing like .NET console application demos where I'm using Jupyter notebooks. So Jupyter notebooks traditionally were used by data scientists to interact with machine learning, but you could actually do a lot more with it. And I discovered that a couple of months ago, where just going to open it up. There we go. Where it allows you to manage to run .NET code straight from within the notebook. So it supports Markdown for like the text layout and everything that you might know from like a GitHub README file or something. But then at the same time, you can make it .NET interactive. And it supports other languages as well, by the way. So what I did, I'll share the link to my GitHub, but not in chat. But I'll make sure that you have it later on. So this notebook that I'll use for some of my demos, you're going to find them on the GitHub as well. Oh, look, I'll help you a bit. So if you go to my GitHub and then search for the Geek Ready, it was a name for an internal Microsoft conference where I presented on the topic. So everyone can reuse this. As always, we like GitHub stars and pull requests if you want to make it more fun, make it more exciting. Then happy to accept your contributions. So in short, I'm not going to read through all of this. I mean, you could all do this on your own side. But where it becomes cool is that .NET interactive mode. So step one here is just writing a little bit of .NET, like console write line. But again, you would do in Visual Studio, go to the terminal, .NET run, .NET build, console write line, I mean, as part of your .NET code. So here I'm just testing, is my .NET interactive mode actually working? Next, we need to establish interaction with our AI services. So I'm just creating a pointer to like a web config JSON file where I'm pulling up the Azure OpenAI service, the endpoint, what we had from our AI service deployment, the specific model I'm using, and the API key. So just handing over parameters to your app. So let's do that import, all fine. Next, I'm injecting the Semantic kernel SDKs over here. So basically importing the NuGet packages if you're a bit into .NET development. And then from there, I'm like, hey, you can use this AI service using the parameters endpoint, the key that I provided you earlier. I should actually update the package because it's a little bit outdated, but still supported. So that's the baseline. So the next step is now adding intelligence into our application. Now, not all examples here, I would say in the demo, require Semantic kernel as that RAG architecture. So the first example here is find a country capital. So you, in this case, it's like, I don't know, simulating a travel assistant where you would do something like, I want to travel to Belgium, my home country, and I want to know about the capital. I want to know the airport code. I want to know what to visit. I want to learn about the food. I mean, in the meantime, you know, Peter likes food. And that's mainly what I try to do here. So the starting point is find a country's capital. So how does this work in Semantic kernel setup? It's actually pretty easy. I would say the hardest part is importing the Semantic kernel packages into the .NET application. Because from here, I would say the focus point is go into the application local directory, find the folder plugins, and inside find the setting folder called city plugin and load the plugin. So what do we have is our application code here on the side. I go into the folder plugins, city plugin, and there's two different files, a config JSON and a Semantic kernel prompt text file. Inside the prompt text file, that's where you would write basically the prompt that you would use in like Copilot itself, where you would go into Copilot connecting to your large language model, and you would do something like, tell me the capital city for Belgium, New Zealand, whatever country you're looking for. So now you're going to translate that into a prompt and then writing a variable. So my input is country, and the input means this is what I get from the prompt. And then the config is where you're going to define the technical settings, like this is how I want to interact with the large language model. A description, that's details, but then also, again, here defining the tokens, the temperature. So we talked about tokens before. In this case, a capital name, you don't need 10,000 tokens to do that because it's typically 1 or 2 words. It's like maybe 20 characters. So even 100 tokens is actually way too much. The temperature is the large language model parameter that you would use to provide accurate information or use a little bit more freestyling. So if you think about a capital name, it needs to be correct, right? There's only one capital for each country. So that's where you're going to lower the temperature. If you want to create something more artistic, help me writing a poem, help me writing lyrics, help me creating a DALI image, that's where you're going to see that the temperature number or the value is a lot higher to provide more flexibility, freestyling to the language model. So translating back to our .NET code, it's, well, my dear Semantic kernel, you can go into this folder. I'm going to give you the prompt that you need to use. And from there, I want to get a response. And then using this, I'm going to load it and then executing. So I'm providing an input Belgium, and it tells me, again, console write line, the outcome of Belgium as a country. Hey, can you help me providing the capital name? That's my prompt in the backend of the config file. And the answer is Brussels. Now, to show you that it's still relying on the large language model, if I change this to, for example, Seattle, I hope we can all agree that Seattle is not a country, then it's, you would assume in traditional applications, it would tell you like, oh, too bad, I cannot answer this because there's no correlation between Seattle being a country. But now your generative AI is still providing the natural language response where it's telling you, well, I found out in my trained model that Seattle is actually not a country, but it's a city in a country. And since the purpose of my semantic kernel is, if you see the country name, please map it with a capital, it's actually still doing that. So that's, again, that augmented intelligence that you're going to bring into your applications. And if you're a developer, this would be like a more complex try-catch scenario or the if-then-else scenario. We're now just out of the language model and semantic kernel, it's fixing that for you. So from here, we can move on. So I'm doing about the same. Based on the plugins city plugin, I now want you to find the airport code. So there is obviously part of the trained model. It has an idea of all official airports across the world and what is the official IATA Airlines, International Airline something code. So based on, again, my input Brussels, it's now going to tell me that the airport code is BRU. From here, you got the country. We're going to Belgium. We got the capital, and we know, like if I would go to whatever airlines website and ordering my flight, I could now use fly from SEA Seattle, closest to me, at least as the airport, and then flying to BRU, which is Seattle to Brussels. Now, up till now, my semantic kernel assumes that out of the plugins, we get access to the file system. But that's not always the case. If you have an app that's running inside functions, if you have an app that's running inside containers, then maybe it's not always recommended to have all those parameters and little plugins hard-coded as part of your file system. Or if it's, let's say, a mobile app that you're going to publish, allow a user to download. In a lot of those cases, you don't get access to the local file system. So that's where you have the same concept, but then now we call them inline functions. What we're doing here is basically the same. We define the prompt. So we're going to ask something like, what's the weather today? Who's the prime minister? Whatever prompt you could think of within your solution. I'm asking, write me a riddle about Belgium. And I'm still providing the config settings. But now instead of having those in a text file, it's literally embedded in the .NET code. So now it's coming up with a riddle. I'm a city in Belgium, diamond capital of the world, and tada, the answer is Antwerp. So pretty cool. The other option, integrating images. So same thing, a lot of text, feel free to read through. I'm going to load my kernel. Where now I'm using text embedding. Why in this demo scenario? I'm asking, first of all, to, based on, again, Belgium as a country, Brussels as the capital, can you find a popular landmark, like something that everyone would typically go to as a tourist, right? And provide a description from it, and at the same time, use the output from the prompt, like the prompt completion, as the text embedding, and use that as an input for DALL-E. And I'm going to run this. Typically takes a little bit longer because it takes a while to actually compose that image. So it's providing details about Brussels, Belgium, you already knew, and now it's picking the Grand Place, so the big market, you could say. And based on this description, this would now be the same as, hey, my dear Copilot or any other scenario, can you please create me an image from the Brussels Grand Place? And then it's nicely coming up, and I think that's quite accurate. And then obviously, I'm still providing the link to the actual image, similar to what like Copilot is doing. Last example here, there's few more, but it's all based on the same context, is planners, where now the planner could be replaced with like a scheduled task, you could say. So one example I have here is interacting with food. So I'm providing it a location. So I want you to provide me input on how I can actually make my Belgian beef stew. It's a super famous dish that we had in like my region of the country. I don't know how to make it. In the meantime, I do. But that's like providing all the details. Same thing, like create me a shopping list. Same concept. I'm creating shopping plugin over here in my file system. Get grocery list. Behind the scenes, there's a prompt. You are acting as a shopping assistant for whatever store you want to go to. And I want you to use the input is the food recipe that we had in the previous step. And then it's nicely coming up like, oh, you need X amount of beef chuck, you need some flour, you need salt, you need butter, and so on and so on. All that information is now pulled in real time. So if you think about agents, like one of the big announcements, I think like 2-3 days ago, with the OpenAI agents, that they're actually going to allow you to book airlines flights for you, to do the shopping for you. It's all based on the large language model, but then extended with the augmented retrieval architecture. So now you could actually go in as far as like, if you know that your favorite store is, let's say, Walmart here in the US, then instead of asking it like, oh, can you build me up a shopping list, would be a plugin to connect to the APIs from Walmart, pulling up the whole product list from Walmart, right? And then fine-tuning your shopping cart. And then obviously the next step is like, now you got my shopping cart, I'm going to give you approval to order it. And by the way, these are my credit card details. So that's, again, in short, how it works. So I guess with that, we're 100% on spot on the time. So perfect timing. happy that the demos work. So I don't know, Luke, if we got any other questions in chat or something you wanted to ask or add into it.
No, that was great session. Thanks, Peter. Very, yeah, it's forefront of mind at the moment, and it's changing so quickly. I did post in the chat the link to the Semantic Kernel Applied Skills Challenge, but they, of course, are down for maintenance at the moment.
Okay.
But
yeah, even those ones are changing as fast as generative AI itself. So there's a reason why they're down.
But it's good to have that kind of methodology to go, oh, instead of going and doing a full certification course on, AI Engineer 102, you could just go, right, I want to learn about semantic kernel. So the applied skills give you a great chance to do that one task. But yeah, definitely keep an eye out for that. But I don't think there's any more questions in the chat. But thank you, Peter, for coming and sharing your breadth of knowledge with us all.
Always fun. Thanks for having me.
Yeah, I'll stop the recording, but yeah, I don't think there's any more questions. Yep, we've got the links to the GitHub repo and stuff as well, so I'll put those in the chat for everyone. But yeah, thank you for coming and sharing your knowledge with us today, and hopefully people learned something.
I hope so. And I would say if